Hello, I'm here with my friends, partners, Miguel, Michael, and Iberian. What we're about to do, an experiment, is on the crystallization process of sodium acetate and hand warmers. The purpose of this is to determine how starting temperatures affect crystal growth and heat generation. To do this, the packs will be dipped into water at 3 different temperatures, 0, 20, and 40 degrees Celsius. When the packs have attained these temperatures, they will be activated and observed. The temperatures will be marked every 15 seconds for 3 minutes.
Go.
Hello, this is going to be the first trial. It's going to be at 20 degrees Celsius. Right now we'll be testing the sodium acetate reacting in hand warmers. It's pretty much going to be, we're going to dip it in until it acclimates and gets to the same temperature, which is once again 20 degrees Celsius. We're going to take it out and we're going to be able to observe the temperature change as well as the crystallization process. If I can get it open.
Other side. Other side.
Oh.
There's a little slit. Other side.
What? Oh, okay. Sorry for the delay. And here we go. It'll be dipped in for 5 minutes.
Go.
Alright, it's been 3 minutes, and as you can see, we've already completed our 3-minute trial, as I've already said. So right now we're about to open up and see what we can find. Alright, judging by what I have in front of me, we can see that the crystal formation is minimum. So as I've already stated, this is the 20 degree as in room temperature trial. As you can see, it's a very, very fine granule structure. No crystals whatsoever, any large or complex, and it's in a powdered form. That'll be it.
As part of this experiment, we are going to test the heat output and the crystal growth of the sodium acetate hand warmer inside of the 0 degrees Celsius water. And I will put this hand warmer in the water as soon as I open this packet, and we'll begin to wait for the hand warmer to reach equilibrium of the same temperature with the 0 degrees Celsius water. Now that we finished measuring the heat change within the hand warmers, you can see that we've observed that there is a trend within the heat increase, and between 15 seconds through a minute at least, I think.
Through 3 minutes.
Through 3 minutes. And we saw that there was a trend going on there.
And slightly lower temperatures.
Slightly lower in temperatures. It kind of varied within the time period, but now opening up the bag of the hand warmer, you can see that it's a little clumpy at first.
Let me get a better view of it. I figured I might as well just talk in the video too.
It's kind of clumpy too. Like, you can see that it's a little more clumped together than the last one when it was more fine with the room temperature water. There's some crystal formation going. You can see, as you can see right here, there's some crystals that are forming. But overall, it's a little bit clumpier than the last one, and really not much difference.
You can talk too.
There's more complex crystal formation in this one.
LeBaron's idea.
Yeah.
Very good observation, LeBaron. And that's about it. We'll give a closer shot of it real quick. Now for the latter part of our experiment, we are going to place a sodium acetate hand warmer into a 40 degrees Celsius water bath and let it acclimate. And then after it's reached the same temperature as the water, we will take it out and test the heat output and the crystal transformation of it after it's been in the ice bath for about 5 minutes or so. So right now we'll go ahead and show you the temperature of the water bath, and it's about 40 degrees, and we'll leave it at that. And at this moment I will place the sodium acetate hand warmer into the ice bath, or into the 40 degrees Celsius water bath. We just now finished the heat observations of the 40 degrees Celsius starting temperature of the sodium acetate hand warmer, and this is what our results look like. Starting at a higher temperature, initially there was a higher jump in the temperature at the first thing at the first to second interval, but then we notice a completely negative trend afterwards, which we believe is from the hand warmer. Once it reaches a specific heat retention, it begins to slowly decline, as shown here in our experiment. And now we're going to go into the crystal formation of the hand warmer, which we'll have right here. Right off the bat, if you can try to get a little closer, you see a couple of solid clumps of the crystals, and then right there, as you notice, it just broke apart. So maybe we're observing that the heat caused a sort of bounding of the hand warmers, and as we look farther, there's still more clumps, and it seems to have clumped more than usual and kind of solidified it better with the hotter temperatures. And maybe that's from it when it cooled down from the hotter temperatures, but that is about all the observations we have seen so far. You can just stop. Go.
The science behind this in simple terms pretty much amounts to this. The solution within the bag is composed of a supersaturated sodium acetate solution. Supersaturated meaning that the solvent has more solute than naturally possible. By snapping a disc with the pack, you release a crystal form of solid sodium acetate that causes the supersaturate to crystallize. This crystallization is exothermic, meaning that heat is emitted. For every gram of crystal formed, 264 joules of energy is released. The results are simple. At room temperature, a slight trend was observed. We started at 22 degrees Celsius and ended at 24.1. At 0 degrees Celsius, we started at 13.5 and ended at 23.5. And at 40 degrees Celsius, we started at 36.6 and ended at 25.3. Thank you.